Hi, today's lesson is about solving a system of inequalities graphically. Please notice that when you solve a system of inequalities, that means that you are solving, in our case, both of them simultaneously on one coordinate system. Graphically, you will show where the two solution sets overlap. You will have to remember to state the coordinates of a point in that solution set. Notice that the second inequality is written in a form where y is already isolated, which is convenient because it allows us to see the y-intercept, -4, and the slope, 2/3, of the boundary line for this equation. So the first point we can plot is at y -4, and the second point could be found by going 2 up, 3 to the right. 2 up, 3 to the right. It's the second point. Notice that the sign of the inequality is greater than or equal, which means that we will need a solid line. The sign also tells us where we shade the solution. Since it is greater than or equal, we will be shading above. So now, in the blue area, we can find all the points that make the first inequality true. Remember that if you had a trouble identifying the y-intercept and slope to find your boundary line, you could use your calculator by dialing the equation of the boundary line, observing how the line goes through the coordinate system, and taking the coordinates from the coordinate table. The same process we will have to repeat for the other inequality we haven't touched yet. Let's copy it first. Notice that the y is not alone here, and that is something that we will have to do. If you are puzzled with what should be the first step, then let's begin with identifying the term that contains the y. Circle it with its sign and indicate that you will rewrite it in the first position, so that in the new inequality it's easier to see that when you get rid of the term 3x, its sign is positive, which means that you will need to undo it by subtraction. Subtracting -3 from both sides will lead you to a new inequality, which will preserve the sign. Remember, sign only changes if you divide or multiply by a negative number. Since your y is isolated, you now could tell the y-intercept 7 and the slope -3/1, which means that your first point will be at y +7, right here. And you will find the second point by going down 3 units and going to the right 1 unit. This is your second point. Slow down before you plot the line, because you need to pay attention to the sign again. The sign is less than means that you will have to use a broken line. Notice that the same sign, is less than, means that you will shade all the values that are less than your y-intercept. Therefore, it will lie below the line. So now you clearly could see that the point where the two boundary lines intersect breaks the coordinate system in 4 regions. In the first region, there are no shades therefore none of the inequalities has their solutions. In the second region, only the green inequality has the solution. In the third region, both shades happen to be, which means that this is the region where both inequalities have their solutions, which is exactly what we were looking for. It's a good practice to mark the area where they overlap with S, which stands for solution. To check your work, we will pick any point in the region 3, which indicates the solutions are here. It is convenient to work with the point 0, 0. Since it's lying in the shaded region, it will or should make both of the inequalities true. So you will take the original, that's very important, original inequalities, dial them on the calculator with the test button, and verify that left side indeed is less than 7 for the first inequality, and left side is indeed greater or equal to than the right side in the second inequality, which means that the point 0, 0, which remember lies in the overlapped area, indeed represents the solution of this system of your inequalities. And that concludes our solution.